Alright, so in this video, we're going to talk about the converse of the same side interior angles theorem. And the whole idea of the converse of the same side interior angles theorem says that if a pair of same side interior angles are supplementary, then the lines must be parallel. And that's really the whole idea. So our whole goal in this video is to prove that if these two angles are supplementary, that these lines are parallel. So, to do that, let's first construct our statements reasons table. For our first step, what we're going to write down is what we're given. Now, for our second step, we're going to identify this angle as angle 3. And what you can notice here is that angle 1 and angle 3 form a linear pair. The reason why they form a linear pair is because that comes from the definition of a linear pair. If you recall, a linear pair is a pair of angles that form a line. We can see that angle 1 and angle 3 form line L. For step 3, we can apply the linear pair theorem, right? What that says is that if two angles form a linear pair, then they must be supplementary. So we know for a fact that angle 1 and angle 3 are supplementary. Now notice that both angle 2 and angle 3 are supplementary to the same angle. As a result, these two angles are congruent. That's the congruent supplements theorem. So we know for a fact that angle 2 is congruent to angle 3, and this is by the congruent supplements theorem, if you recall. But angle 2 and angle 3 are alternate interior angles. And if you recall, the converse of the alternate interior angles theorem says that if a pair of alternate interior angles are congruent, then these two lines must be parallel. So now we know for a fact that line L and line M are parallel. And so as you can see, we have proven exactly what we wanted to prove. And so yeah, that's the whole idea of the converse of the same side interior angles theorem, right? And yeah, that's pretty much the whole idea of it.